All right, so for notes 5.2, we're going to be looking at finding the rate of change from a table and a graph. So the first question that we see says, in a given table, how would you calculate the rate of change? Well, we've been doing that all along. We've been calculating rate of change. We've just been calling it something else. So far this year, the only thing that we've called rate of change is change in y over change in x. So really all we're going to be looking for is what our y's and our x's change by each time. So on this first table, what I'm going to do is look at the y column. I'm going to say, all right, from 6 to 4, it decreases by 2. And then from 4 to 2, it decreases by 2. And from 2 to 0, it decreases by 2 again. Then on the x side, when I look over here, from negative 10 to negative 5, it goes up 5. And from negative 5 to 0, it goes up 5. And from 0 to 5, it goes up 5. So I'm looking for the change in y over the change in x. Each time, my y changed by negative 2, and my x changed by 5. So my rate of change is negative 2 over 5. All right, so on the following tables to find the rate of change, I'm going to snapshot them so that I have a little bit more room to write. For the first one, I have my y values from 7 to 11, change by 4, 11 to 15, change by 4, and 15 to 9, change by 4. From 2 to 4, x changes by 2. From 4 to 6, x changes by 2. And from 6 to 8, x changes by 2. So if I'm looking for the change in y over change in x, also known as the rate of change, I would put my change in y, 4, over my change in x, which is 2. So I end up with 4 over 2. But I notice that that's a fraction that I can reduce. 4 divided by 2 is 2, so it just reduces to the whole number of 2. Therefore, the rate of change for this table is 4 over 2, and that's what we were asked to find, is the rate of change. Okay, and then for the other table there, when I look at my y values, from 23 to 37, the rate of change is 14. And then from 37 to 44, the rate of change is 7. And then from 44 to 65, the rate of change is 21. So some people get a little bit nervous when they see numbers in the change in y that are different, and they're like, oh, wait, there's not a constant rate of change. But that's not always necessarily the case. You have to go across and check the x column and see if it might reduce to the same number. So when I come over here and look at x, the change from 4 to 6 is an increase of 2. And then from 6 to 7 is an increase of 1. And from 7 to 10 is an increase of 3. So what I'm going to do is check the change in y over change in x for each interval. So here I have 14 over 2, which 14 divided by 2 is 7. So the rate of change is 7 for that interval. And then on the next one, I have a rate of change of 7 over 1, which is 7. And then on the last one, I have 21 over 3, which is a rate of change of 7. So each time as I calculated the rate of change between the points, I got 7, 7, and 7. So because it reduces to the exact same thing every time, then that means that I do have a constant rate of change, and the rate of change for this one is 7. So there's lots of different ways in math that we say the rate of change. Probably the most common way that you're going to hear any math teacher refer to the rate of change is by using the word slope. So that's your first blank right there. Okay, you may also hear it referred to as the vertical change, ran out of room there, over the horizontal change. Another way that you may hear slope referred to is rise over run. One that you're really familiar with by now is delta y over delta x, which literally just means change in y over change in x. Or you may also hear your teachers refer to slope as steepness. But know that all of these words mean the same thing. And if you ever need to remember some words that mean rate of change, in my classroom there's a poster. It's kind of up and to the left of the smartboard, and you can look at that poster, and it says slope, and it has all the words on it that mean the same thing as slope. Okay, so another really, really, really important thing that you need to know, this is like big idea for Algebra 1, is that if a line rises from left to right, so if it's going up, that means that it has positive slope. If a line is going down, or if it falls from left to right, it has negative slope. Horizontal lines have zero slope, and undefined lines have, vertical lines have undefined slope. And I'm going to give you a trick to remember those here in just a second. Also know, in my classroom, right above the smartboard, because I think it's probably one of the most important ideas that we cover, is a poster that says the exact same thing. So if you're in class, you can't remember which one's positive and which one's negative and which one's undefined and all that good stuff. Positive, negative, horizontal line with zero slope, and vertical line with undefined slope. That exact same poster is right there at the front of the room. Okay, so here's what we're going to do. I'm going to teach you how to calculate the slope of any given line. And the directions say to find the slope of a line, pick any 2 points on the line, count up, which acts as your change in y, and then count over, which acts as your change in x, to the next point. So this picture, I think, is a little bit misleading, but I want to make sure that you understand exactly what it is that I'm talking about. We're looking to calculate the slope of that line right there. That's what I'm trying to do, is find the slope of that line. So to do that, I have to look at the ordered pairs that this line has. Here's one, here's another one, here's another one, here's another one, okay? So what we're going to do is count up and then count over from point to point. So if I start here at this dot, I would count up 2, and then I would count to the right 1, 2, 3. So what that means is my change in y, that was my up, was 2, and then my change in x is 3. So we always put the change in y over the change in x, and the slope is 2/3. So the slope of this line right here is 2/3. So let's look at another example here. Okay, a really important thing that you have to do is figure out where the line crosses through the crosshairs. This is a crosshair right here, this little TX thing right here. Okay, so you have to pick a place where this line crosses through crosshairs. So I can see that it goes through here, and another spot that it goes through is right there. So to find the slope of this line, I have to count up and over to see how many I have to go. So I count up 1, 2, and then I count to the right 1, 2, 3, 4, 5. So I counted up 2, right 5, which means that I have a slope of 2/5. Also notice that this line is going up. It is increasing, which makes it a positive slope. So because the line is going up and to the right, I have a positive slope of 2/5. On example 2, you might notice that the line is falling, which means that it's decreasing. So automatically, that's going to tell you that the line has a negative slope. So I'm going to look through some of the crosshairs here to see where the line goes through exactly. I can see it goes through right there, and I can also see it goes through again at about 4/2. So this time I have to count down. So since I'm counting down, that automatically should tell me that I'm going to be having a negative slope. So count down 1, 2, 3, and then I count to the right 1, 2, 3, 4, 5. So I counted down 3, which I represent with -3, and then right 5. So my slope on this one is -3/5. Okay, then on example 3, I have a line which is horizontal. So anytime you have a horizontal line, that means it has a slope of 0. And one of my good teacher friends taught me this little trick. If you write the word horizontal, because you can realize that it's a horizontal line, see how the word horizontal has a Z in it? Well, if you come over here and look at, oh, okay, back in business. My slate decided to quit on me. Okay, if we go back here, we were writing the word horizontal, and it has a Z in it, and if you look at your horizontal line and the x-axis, you can make a z out of them. So the word horizontal has a z, and you can make your horizontal line and your x-axis into a z. To remind yourself, because of the z, they have that a horizontal line has 0 slope. Okay, then for a vertical line has a slope that we call undefined. Oops, if I could spell it, that would be even better. Undefined. Okay, the reason that it's undefined is that any point that you pick on this vertical line, remember slope is defined as the change in y over the change in x. So if I start here and go up 1, 2, 3, I can't go right or left any, so I get 0. So this is 3 divided by 0, and there's no possible way to divide by 0, which is why we get undefined slope. So anytime that you have a vertical line, the slope is undefined. And another trick I learned for this one is if you write the word undefined, it starts with a U. And if you look at a vertical line and the y-axis, you can make a U out of them to remind yourself that the slope is undefined. Okay, so for example 5, we are going to pick a few points and see if we can figure out what the slope of that line is. A really good place to always start looking is to see if you can pick a point on the y-axis. There will usually, not always, but usually be a point on the y-axis that the slope goes through. So right here I can see that this line goes through 2. Then I can see that it goes again at 4, 5, and it goes through again at, excuse me, that was at 4, 4. Let me see. No, I was right the first time. 4, 5. And then it goes through again at 8, 8. Okay, so what I'm going to do now is I'm going to look at these points, and it's always a good idea to get at least 3 points so that you can double check to see that you actually got points that were on the line. So I'm going to count here. I'm going to go up 1, 2, 3, and then I go to the right 1, 2, 3, 4. So I went up 3 over 4. So my slope of this line is 3 over 4. And because it's an increasing line, and that means that it has a positive slope. So then, for example 6, I'm going to increase the size of that just a little bit. Okay, so on example 6, I can see the place where it crosses on the y-axis. Remember I said that's always a good place to start. Is it crosses right there on 5 on the y-axis. And then another point that it goes through is 2, 4. And then it looks like it goes through again at 4, 3. And then again at 6, 2. Okay, so I can tell by this line declining that it's going to have a negative slope. Sometimes I go ahead and write that negative down just so that I don't forget. Actually, we're writing down here, I forgot. So our slope is negative. And I go down 1, right 2. Down 1, right 2, down 1, right 2. So I went down 1, right 2, which means that that line has a slope of negative 1/2. Then on example 7, I'm going to go and look to see it crosses right here on the y-axis at negative 4. And I'm going to pick a few more points here just to double check, make sure I didn't get off. But I can see I go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So really I'm going down 1, right 1, like that. But I can reduce that whole thing to have a slope of negative 1. So slope can either be a fraction or it can be a whole number, either one. Decimals are not ideal. It's best to leave them as either a fraction or a whole number. Then for example 8, for example 8, I can see that it crosses the y-axis right there at negative 3. And then I can see it goes through again right there at 1, 1. And then another time it goes through at 2, 1. And then it looks like it goes through again at 3, 3. So if I count my order pairs to see where they cross, I go up 2, right 1, up 2, right 1, up 2, right 1. Because the line is going up, I know that it has positive slope. So I went up 2, and then I went right 1. But because this can be reduced, I'm going to go ahead and reduce that to the whole number 2. So the slope of that line is 2. And then on the back of the notes, if you look, there's some word problems here, not necessarily word problems, but just graph with words on them, and you have to figure out what the slope is trying to represent. So if you look at the graph, you can see that the x-axis is representing time in hours, and the y-axis is representing the cost in dollars. So the first thing you have to do is find the slope of the graph. I can see that it goes through right there at 0, 0, so that's one of the spots. The next place it goes through is at 130. It goes through again at 260, and then for the last time it goes again at 390. So each time we moved, we went up 30 over 1, up 30 over 1, up 30 over 1. So the slope is 30 over 1, which I'm just going to reduce to 30. So that's my answer to part 1. And then it says, what does it represent? Well, if you look at your axis, that'll kind of help you figure out what it's trying to represent. So here on cost in dollars, the cost went up 30, and then time in hours went over 1. So cost went up 30, hours went over 1. Cost went up 30, hours went over 1. So what this would represent is that for each hour, the cost increased $30. Okay, then on example 10, it says to find the slope again. So I can see that it crosses through there at 0, 0. Another spot that it crosses through is at 3, 2. And then the last spot that it crosses through is at 6, 4. So we go cost in dollars on the y-axis, weight in ounces on the x-axis. So the cost goes up $2 when the weight in ounces goes over 3. The cost goes up $2 when the weight in ounces goes over 3. So the slope is 2/3, and it represents that for every 3 ounces, the cost goes up $2. Then on example 11, it wants us to find the slope of this line. Automatically I can see that it's decreasing or going down, so I know that because it's going down that way, I know that it's going to have a negative slope. I'm going to put my negative sign there so I don't forget, because I forget that sometimes. So I find the points where it crosses through exactly. I can see it crosses through the y-axis right there at 250. It crosses again at 5,200, and then one more time at 10,150. So from here to here, we go down 50, so the height of the football is our y-axis, and time in seconds is on our x-axis. We go down 50 over 5, down 50 over 5. So the height of the football decreases by 50 as time increases by 5. So down 50 over 5, which can actually be reduced to -10. So I'm going to put the slope as -10. And then it says, what does it represent? So for that, I would say the height of the football decreases 10 feet every second. And then for our very last example, we have a table, but you basically still do the same thing. Slope is change in y over change in x. So here I'm going to see from 720 to 1080, the change is $3.60. From 1080 to $18, it changes by $7.20. And from 18 to 2520, once again, it changes by $7.20. Now, just because you see different numbers here, don't like freak out and say, oh, well, it's not linear, it doesn't have a constant rate of change. Well, you have to come over here and check this side and see if it reduces to the same thing. So from 2 to 3, the change is 1. from 3 to 5, the change is 2, and from 5 to 7, the change is 2. So if I try to reduce that each time, I have 360 over 1, which would reduce to 360. And then for the second 2, I have 720 over 2 both times. So 720 over 2 reduces to 360. So the slope for both of these is 360. And if I look, my x-axis is being represented by people, and my y-axis is being represented by cost in dollars. So that means that for each person, the cost is $3.60. And that's it. And then for homework 5.2, the assignment is going to be in class, page 314, number 4 through 10 even, 14 through 18 even, 22, 30, and 34 through 38 even.